So thank you all for coming. I'm Andrew Brandt. I'm the Director of Threat Research at Blue Coat Systems, which as of Monday is Symantec. I run a malware research lab in which we detonate a few million samples a week and observe the behavior on both the endpoints and over the network. The specific lab that I work in does deep research into APTs, Internet of Things, mobile devices. I mean, kind of a broad spectrum of bad stuff and broken stuff. So today I wanted to talk about the SSL Visibility appliance, which is one of the pieces of kit that I have in my lab, and it's also one of the products that the company sells. Now, this isn't a product pitch, but there's a few marketing delivered slides that are kind of sprinkled throughout, and the only reason they're in there is to put speeds and feeds and some other stuff in there, and you'll be able to tell the difference really well. Plus, I'm not going to make a sales pitch for this stuff. I'm just talking about how I use it in the lab and why people use it, and maybe I should just go to the first slide, and also why businesses use it and why they're interested in it and how it works, what it can and can't do. So Blue Coat has a bunch of lines of business, or I'm going to assume Blue Coat is a separate company for the moment, just because. Started out as a company that sold proxies, and then they bought a company called Cashflow, which does bandwidth management, and they did that for 10 years. And everybody who knows about Blue Coat basically thinks of them as that company that sells proxies to companies that want to do filtering and stuff on the internet. And as a side business of that, the research division for Blue Coat does a lot of work on URL categorization. Some really smart people who are experts in linguistics and all kinds of weird math theories as well. And we do all this analysis, and some of it automated, some of it manual, to classify URLs as good, bad, or when they're good, into a host of other subcategories, so that you can basically decide on the proxy how you want to, what you want people to be able to get to while they're on your network. In 2013, they bought a bunch of security companies and kind of rebranded themselves into the security space a little bit more. And I was from one of those companies. I was the director of research at Solera Networks. Solera made a product called DeepSea, which is now called Blue Coat Security Analytics. They also bought Norman Shark, which made the Norman Sandbox and Norman Malware Analyzer, and now is called just Malware Analysis. And then they bought some technology from a company called Netronome, which does, they had some custom silicon that they patented, which is specifically for crunching the math involved in doing SSL decryption, and the technology and some of that stuff is now in the product that's called SSL Visibility. So and a lot of our customers are some of the biggest companies in the world in a whole host of industries, and almost certainly, like, if you bought a coffee today or filled up your gas tank or like went to the store in the last week, one of those businesses probably is using some of our stuff to protect their own internal networks. And, we like to think that that's a good thing. So I want to talk a little bit about the SSL Visibility, but I need to give you some context. Is that how I'm going to show you the decrypted SSL is through the lens of security analytics, because the SSL Visibility product doesn't actually do anything except decrypt the stuff and then spit it out into another sort of span port. So even though it gives you some logs and stuff, that it doesn't really give you a whole lot of context as to what's going on. So most of what I'm going to be showing you is security analytics. And what it is it's a full fidelity, high-speed packet capture system that, as the packets are all sprayed out onto the onto disk, passes them through a DPI engine, which then extracts several hundred metadata attributes about the packets and indexes all of those attributes, and then allows you to do things like search for traffic that is interesting to you in a very free-form way. And when you have found something of interest, it will reconstruct some of the types of artifacts like HTTP and SMTP and just a whole bunch of stuff. So, and yeah, this is what I talked about basically, and the gist of it is that SA is a retrospective analysis tool, and it isn't focused on any one thing. It basically allows you to search for whatever you want, and it can't block anything because it's an out-of-band network tap, and as such, it's basically just everything that you see in security analytics is what happened from 1 second ago, going back in time to as far back as storage you have to store all of the network data. So this is just a screen grab of the UI on a monitor that was not 1024 by 768. So it shows basically that there's different little reportlets that are shown on this dashboard are the different metadata attributes, and it kind of shows some flow counts for each of those during the time slice that's indicated in the upper right-hand corner. And the big rectangular bar is the metaphorical equivalent of the browser address bar in that it allows you to kind of narrow your searches, and that's where you would search for different metadata attributes in the product, right? And this was my favorite quote of the year. So back in February at Usenix, the guy who's the head of NSA's TAO was giving a talk, and he gave this great quote, which is basically that out-of-band network capture, where people are actually paying attention and looking at the stuff, is their worst nightmare, because it's the kind of security solution that even nation-state hackers cannot detect is present on the network, and it will reveal their activities. It's the best sales pitch ever for us. So, so what's SSL Visibility? So it's this box that is a standalone SSL man-in-the-middle box. It has this UI for creating, maintaining, managing certs. It is an inline device, meaning that it has one port for inbound ingress traffic, one port for egress traffic, and then a bunch of other ports for just basically that's where you would put your tap feed out ports. It doesn't do a whole lot else. In fact, it pretty much only does the decryption and has a bunch of logs that you can look at to kind of see what's happening on the box, but it doesn't show you any of that traffic per se. So this is the main reason why people are interested in SSL decryption in kind of a corporate, big enterprise environment, is that a lot of CISOs understand that if not, it's not a large part of their threat traffic, right? So in our estimation, 10 to 15% of malware is using SSL in one way or another, either for command and control to pull down payloads, something like that, exfiltrate data. But the stuff that's using it is the worst stuff that's out there, and so these guys know that there's a visibility gap in these like really bad pieces of malware, and they don't know. They want to be able to answer the question when the boss calls them up and says, "There's been a breach. What did we lose?" They don't want to have to say, "We don't know." So that's why they are interested in this stuff, right? So this is what the box actually looks like. It's a half-width 1U server. This particular one is the smallest one, called the SV800, but there's bigger ones that are 1U and 2U and 4U, and they're all capable of doing different performance levels on SSL decrypt. But basically, what you need is the box that does the decryption and something to take that feed and store the packets and let you search through it. And so that's what we use SA for. Right, and I said it plays well with others, right? So it can feed out to tons of other products, whether it's an IDS or an IPS or next-gen firewall or anti-malware tool, whatever it is. It doesn't matter. We play well with everybody. All right. So here's the user interface walkthrough, and this is the really boring part, and I'm going to go through it fast because it's the really boring part, and I want to show you the cool stuff that we're able to find with the tool. But this is the important part of the talk because it's the part that I think there's the most misunderstanding and apprehension about, and it's important to understand it. So the first thing, when you set the box up in your network for the first time, it has its own self-signed cert for doing it. Everything is done through an HTTPS browser-based UI. So the first thing you're going to see is, whoa, did it just go by itself? Sorry. Something popped up in front of this window. Go back. So you're going to see the self-signed cert alert, and you have to bypass it by hitting the the acknowledge thing and just allow it to talk. Once you've done that, then you have a default username and password that you log in with, and it prompts you to change that. Now, by the way, like, you know, just wanted to show, like, this is what the self-signed cert looks like, so that if you're kind of curious to know what it is, it's just it's a cert that's on the box. It's generated at the time the install happens, and it just is, you know, you can see it's just a self-signed cert, and it doesn't even have, I guess it has, this is an older box, so the validity expired on this one, but basically it's self-signed for 2 years after you first turn the box on. Yeah, you could, but until Monday we didn't work for Symantec, so, you know, look, that association is brand new, and it's possible that will happen in the future, but there's a lot of appliances, and when you buy them off the shelf, they have their own self-signed cert that's just installed, and that's pretty standard. So this is the UI that pops up when you first see it, and this is about as pretty as it gets. So it's got this little diagram that shows you what the UI, what the front of the box looks like, and the status lights on all of the network ports that are on the front of the box. And so this segment status thing that's just underneath the picture tells you that this box is in the most commonly used mode, which is called active inline fail to network. And what that means is that it is a bump in the wire between the inside and outside of your network, and that if there's any kind of a failure on the network, that there's literally a like 6-inch long Ethernet cable plugged in to interfaces 5 and 6 that just loops back, so that if the box fails for whatever reason, it'll just pass the traffic through, but it won't be doing any decrypting because it'll have failed for whatever reason. And then in this one, it says that the copy interfaces are 3 and 4. So the numbers of the ports are 1 on the left to 8 on the right. And so 3 and 4, the second pair, are where my copy interfaces are plugged into. And I have one that goes to one security analytics box and one that goes to an ESX server that's running a different set of tools as well. So this is the SSL session log. So up in the upper left corner where it says monitor, those are menus, and the first thing in the menu is this thing that just says SSL session log, and this is pretty much all of the data that you're going to see in the UI of the SSL-V about what is happening on the box. And so what this is it's a list of it's in reverse chronological order, so it's oldest at the bottom, newest at the top, and it just constantly feeds down. And it's got the IP address of both the machine that's making the outbound connection and the IP address of the server, as well as the domain name of the server, the cipher suite that's in use, which is actually kind of interesting, whether or not the certificate is valid on the server side. So if you're using this for checking outbound data, and you see a couple of, like, there's one right in the middle there that says invalid issuer, and it's actually whispersystems.org had a bad cert on their server, and it will alert you to that. It'll also alert you to when and there are commercial entities that are using self-signed certs and other like bad certs for their own like business stuff, and it will kind of throw that error. But it shows you the cipher suite. It shows the action tab here, the action column is whether or not the decryption happened. What I'm going to show you next is sort of like how you set up the rules for whether things are decrypted or not, and they're very fine rules that allow you to kind of decide what is appropriate in your circumstances to be decrypting, and what you want to just allow to go through the box because you don't care about it. In my case, because I work at Blue Coat, all the Blue Coat related stuff is I just let it pass through because I don't actually want to inspect the operation of the boxes themselves. But if you wanted to, and you could install the certs on anything that you've got, you can literally inspect everything. And then the status column just says whether or not the decryption worked, and most of them say success, although some of them say alert, because occasionally if you catch a SSL session that's kind of midstream and you don't get the beginning of it and you don't do the cert resign, you'll get little alerts and errors where we didn't get to do the cert resigning because we were in the middle of the session, and you have to get it from the beginning. So this is the UI for creating the certificate, right? And so in this PKI menu, that's one of the menus on the top, you would go to re-signing certificate authorities, and then you would click the little icon that looks like a rose, which is the generate certificate icon, right? And that's basically how you make the cert. You then go into the next page, there's a little pop-up, right? And you can create a cert that has all of the basic information that you would have in an SSL cert, and it's going to have, you know, the org name and street address, but you can put whatever you want, right? So I made one specially for the talk called "This is my DEF CON CA cert," and then these are the drop downs that are in this little pop-up box, and I kind of exploded them out so you could see all of the options that are available to you. So we do varying levels of expiration, different cipher suites, and different like bit lengths on the keys. Right, and then once it's then it just generates it, and it's like, boom, you're done. And basically, these are the details of the cert. So there's two choices that you can do. You can either generate the cert itself, which you then have to distribute to all the boxes that you want to do decryption on, or you can generate a certificate signing request, and you can use that. You can then take that to a a VeriSign type company and go and get that signed if you need to have that signed, and you could use that as well. Right, and so these are the sort of the option. What's at the end? This is what you get, right? So it shows you the details, or it shows you the signing request PEM file, right? And then the next thing you do is you go back to this certificate authorities window, and you can see here's my, I call this my DEF CON CA certificate, right? And you can just select it and hit the export certificate button, and it saves it as a PEM file with the naming convention you see here. And then you can just use OpenSSL if you need to convert it to, you know, CERT or CERT, you know, all the various versions of certificate styles, right? So that's how you make the cert. Now, once you have the cert, in order to do decrypting, everybody who's in the network whose traffic you want us to monitor has to have that cert installed. So you would then, at that point, if you're an IT administrator, I don't know, set up group policy or walk around to every machine and have to install that cert into the certificate store on every machine that you would want to have in your monitoring pool. Any machine that does not have this certificate installed, you can monitor their stuff, but every single flow within an HTTPS session, the browser or whatever is going to pop an error message saying there's a certificate mismatch, and you're likely to being monitored, and you shouldn't go to this site, and you get all kinds of browser errors, and some services won't work at all, and some will just throw up error messages that you can click through repeatedly and really obnoxiously for a very long time before you can actually get through to things. So you do need to actually put those certs on there to make it work in a comfortable way for the end user. Yeah, question.
Is it known a lot of corporate users are used to clicking through that because of how fast the self-signs are from corporate apps?
So the question is, are there a lot of corporate users who are used to clicking through that? And I don't know what the answer is to that. I mean, I guess some people might be. Yeah, it depends. I mean, there are people who will just click OK on any dialog box you present to them just to get it out of their way. But this is so obnoxious and so persistent that it's going to attract attention, or at the very least you're going to notice, you know. And the whole point here is that nobody who's being monitored using any tool like this should be doing so without proper notification, without proper awareness of the fact that they're being monitored, which is why this kind of stuff is only sold into corporate environments where, you know, as a characteristic of your working there, you usually have to sign an agreement that just says, you know, while you're on the corporate network, you know, IT is going to be monitoring what you do. It's pretty standard. Yes?
Have you ever tried asking users whether they know that this is happening and whether they understand it?
I mean, that's
so you're saying that you're expecting that the users are aware of this. And
So the question is, have I ever asked users if they know they're being monitored and if they understand it? And the answer is no. I have never asked users because I'm not user facing. I work internally. And, you know, the laws differ in different countries. Like in places like Germany, there are very strict privacy laws that prohibit the use of certain kinds of technologies, whether or not notification has been given. And it's really jurisdictionally dependent. But no, I've never asked those questions. And honestly, the reality is that you ask the typical user what that means, and they don't really know. So yes, it's a valid point.
But you have companies like Akamai that sit in the cloud anyway, and do things that are kind of like this that nobody agrees to anyway, right? They can re-sign and dumb down ciphers midstream. You think you're going to CNN or MSNBC, but bits and pieces aren't coming from there at all. Your machine, by default from Microsoft or whomever, trusts the cert of the signing, right? So you might be getting bits and pieces from other places, and there may be other players that have access to those keys as well, and you have to click decrypt.
That's true. But they're using other technology, they're doing it for other purposes, and honestly, so the comment that the person made was that there are companies like Akamai that might be doing certificate re-signing and dropping the security level on certain sessions or URLs or flows, and sending that stuff from different places, and presumably that's true. I'm only talking about what we do. But that's a valid point.
Couldn't you deploy the certificate before you installed the device?
Well, you can't generate the certificate until you've installed the device, but you wouldn't necessarily start decrypting until you've deployed the certificates. So you can have this box and have it having all the traffic just pass through it undecrypted until you're ready to flip the switch and turn on the decryption. So that's where we're getting to. I'm glad you mentioned that, because that's what this next step is. So once you've got these certs out there and everything is ready to go, oh, sorry, go ahead.
I was going to say, for some organizations that have internal CAs, if all your workstations already have a certificate that was trusted by your internal CA, right, your proxy becomes an intermediate cert. As long as it's signed by your internal root cert, you don't actually need to distribute enough.
Correct. So if you already have certs installed on your network, we can just take that cert and stick it in here, right? Exactly, or re-sign it or whatever, yeah. So next you're going to set up your policies, right? Because this is going to be how you define what you do and do not decrypt. And so you have to create all these lists of things that you use to set up these rules, and you can set up lists of IP addresses or domain names or certain cipher suites. You know, the WebPulse is the categorization service that's internal to Blue Coat. You can set up for certain categories of websites that you do or do not want to decrypt. So this is what the UI looks like for that. So you create these rule sets based on these lists, and then in my case, I have a bunch of sites that are excluded from decryption, right? So there's IP addresses internally whose traffic I don't want to decrypt anything at all. There's IP addresses externally or domain names externally that I don't want to decrypt, or that the decryption of which would screw things up, like my TV streams Netflix. I can't install my cert on my TV. So if I have this thing on the same network where I'm doing the SSL inspection, it's going to cause Netflix to not work. So things like that. And so in this case, and then the last thing in the step is just decrypt. So this is one of the things I wanted to show, and again, this is one of the marketing slides, so I'm not going to talk about it too much, but the idea is that you can use web categorization to decide the categories of sites that you do or do not want to decrypt. And typically what happens is, because there is a computational cost in terms of what you choose to decrypt. Typically, companies who do this will pick sites that they want to decrypt, or categories of sites they want to decrypt, and everything else passes through. So the stuff like Facebook and Twitter and stuff will pass through, but there's categories in WebPulse for suspicious, malicious outbound, malicious sources, spam, fraud, pornography, and they will want to decrypt some or all of those and just let the rest go through, just to conserve bandwidth and conserve resources. Right. Now this is just some of the UI that sort of defines how the decryption is basically being done, the decode rules, right? And it's got these pretty little pictures that show you how you wire it up. That's all that is. Right? And there's different of these modes that you can use, and for each one there's a different pretty little picture that shows you how to wire it up and make things work, and you can do it in a number of different ways. Right? And then there's failure mode settings. So for example, the Twitter app that you use on a mobile device has its own, it uses certificate pinning, so it has its own built-in cert on the app itself and doesn't use the host cert store that's on your mobile device. And so even if you have a cert installed on a phone, for example, the Twitter app on a network in which the surveillance is enabled will just fail to connect to Twitter because of that certificate pin. So that's one failure mode. And in my case, I've got it set up deliberately to fail because I want to see which apps and which devices have certificate pinning installed. So that's the fourth one down in the column under undecryptable actions, where it says client certificate reject, right? So that's going to cause my connections to fail. But if I wanted to, I could just allow it to pass through and work unimpeded and just not be decrypted. But again, I'm trying to see like what is pinned and what isn't. So I actually want it to throw those error messages in the device when I'm doing that. Yes?
What would happen when Google turn on certificate pinning forever?
That's a really great question. Probably will have a harder time decrypting stuff. Yeah. So, right, so this is where it gets used. So the idea is you can put this inline in your internal network. Say you've got a big enterprise network, you've got all these people at workstations, and you want to be able to do monitoring and make sure that nobody's getting infected with something and beaconing out. So you put it inside the network and you watch you inspect all the sessions that start from the inside and go out. The other use case, or another use case that you can use, is to put it on the outside of a web server that you're using to host some service, to monitor the inbound connections and see what are people doing and how are people trying to break your service in innumerable ways. It can also be used to detect and thwart things like Heartbleed, although of course we all have patched our servers by now, but for the 1 or 2 machines that haven't been patched, it's basically a Heartbleed filter. So all of that kind of stuff that's like weird sessions and oddball sessions will get thrown out and the rest of it will pass through, and you can inspect and monitor your own service to make sure that it's working properly and people are not abusing it. Right. And this is just a pretty marketing picture showing you a map of a network diagram. Next page. Right. Speeds and feeds, just so you know. So at the highest end, right, this thing that's called the SV3800B, it can handle 800,000 concurrent SSL flows. It seems like a lot, but in a big corporate environment, that could be every image on an HTTPS page. You guys are leaving before the good stuff. This is where SSL visibility doesn't get used. It does not get used on large public networks. Even at our highest level, we don't have the performance capability to do SSL inspection on a whole ISP, even on a small ISP. And then the other thing where we don't do it is, and by the way, everybody who works at Blue Coat every single year has to go through export control training so that we all very thoroughly understand what is the Office of Foreign Asset Control's export control list and who is on it, right? And those people cannot have our stuff ever. Right? Again, and I've mentioned this a bunch of times, but I'll just say it again for being redundant. The certificate has to be installed on every device. In certain devices, it has to be installed in multiple certificate stores. Otherwise, it throws lots of errors. It's very obnoxious, and even with the certificates installed properly, there's a lot of devices that display the notification that you're being monitored anyway. It has to have this stuff on it. It doesn't work without it. Right? So this is an example of, like, in Android, when you install the certs on an Android device, it is going to have this persistent notification in the notification bar that tells you there's a certificate installed and that this device can be used to be monitored while it's on a network. You might be being monitored, and if you click through it, it shows you this bigger dialog box that then leads you to the certificate page and allows you to remove those certs. So there's nothing that's going to be invisible to you. right? And the other thing about this is that we're not downgrading the crypto. So if Akamai is doing this kind of stuff and downgrading the crypto, they're clearly not using this tech because we don't do that. Everything that is using a certain crypto suite or a certain crypto level, when we re-sign the stuff, it's using that same suite and that same level when it goes between our box and the client box, so that there is protection at least between your NOC and the endpoint.
Can you dumb it down?
I don't know. That's a really good question, and I don't know why you would want to.
Reduce the load on the backend load balancers or server.
I mean, it's possible. But that would be a great question for a SE. Unfortunately, I just use the tool. I don't actually know all about its internals. So there's a really cool blog post on our site right now that talks about some of the SSL malware stuff that we've been seeing. And as I mentioned, 10 to 15% of malware using SSL or TLS in some way to either infiltrate or exfiltrate. And the stuff that we're seeing that's doing it is the baddest of the bad stuff. All right, so I'm halfway done. Are there any other questions? And then we're going to just go into demoing. Yeah. The speeds and feeds. Let me go back to that.
What is those statistics? What is the emulation size?
Oh, sorry. That's one of those questions that I have no idea. Did it go there? How do I go back? It just doesn't want to go back. Boop, boop. Oh, crap. I did go the wrong way. I'm so sorry. Driving people away. This projector is goofy too because it actually has the top of the screen is at the bottom of the projector screen. There it is. Okay, there. Speeds and feeds. Get your screenshots now. That's all of our stuff. Okay, so does that answer your question? Who was the person that asked that question? Sorry. It doesn't. Okay, I'm sorry. Okay. Boom, boom, boom. Bad stuff. Draws a pretty graph. You can tell the stuff that was made by marketing because I don't do that animation crap. All right, but here's the real use cases. So at B-Sides, I did a really interesting talk. I thought it was pretty interesting. The people who were there thought it was pretty interesting about augmented reality gaming, and the talk was about primarily Ingress, which was the game that Niantic released 4 years ago, and basically is the sort of predecessor to and progenitor of Pokemon Go. So this is the link to the video of the talk, and that video is the whole day's worth of talk. So go to the last hour to see the talk itself. But the gist is that there's this game called Ingress, and it runs on your phone, and it uses geolocation on your phone to place you in the world, and you have to interact with the game at physical locations. And what I did was I used SSL-V to intercept the traffic between the mobile device and their cloud services as a way of sort of starting my research project. And so this is the this is the log from the SSL Visibility UI that just shows the like this is the cipher suites that they're using and some of the servers that they were using. The appspot.com domain that they're using a subdomain off that as their cloud service, right? But then they have all these other API, these analytics APIs that they're using. Right. So one of the things that it does is it's tied in with Google OAuth, and what a lot of people don't realize is Niantic is a spin-off of Google. They were, at the time that Ingress was created, it was an internal Google project. And so it's using a lot of Google services, including OAuth, to basically log you into the game. So this is the session data that was decrypted, showing the Google OAuth keys and the fact that it was the Niantic Ingress app that was making the request. Right, and then Google will respond with an OAuth key and basically say, okay, you're good to go. also, the game communications, all of the game communications, while the transport layer is encrypted, once you've removed the TLS, everything is just plain text JSON. And there's an enormous amount of personal and geological or geolocation data that's transmitted with every in-game action and broadcast out to every player of the game. So the reason that I got into this talk is because there is an epidemic and kind of an arms race of cheaters trying to game the system for their own advantage within Ingress, and then there are other players who are exploiting open APIs and the ability to decrypt the SSL to do huge amounts of data scraping of Ingress to track the cheating players and then report them to Niantic, and that as a result of the fact that there are these enormous databases that profile and lock onto and locate players within the game, some mentally unstable players have been using that information to actually physically stalk and harass other players in the game. So like I said, it's a really interesting talk, so go check it out. But basically, this is showing some of the decrypted stuff that's in the game, which includes all of the text messaging, all of the game event messaging, and tied to that, all of the unique player IDs, unique location IDs, and the Latin long for every event that takes place within the game. So everything is geolocated, and there are these amazing heat maps that show where things happened or where players frequent within the game that they were able to get from the scraping. The other thing that they were able to get, that we were able to get, is some of the API calls to these analytics services, right? So Upside API is what Niantic is using for their in-app purchasing, and to sort of get a baseline for the device, they have this enormous amount of data that they pull down about the device. And again, this is all transported over TLS, but once you've decrypted it, it's all in plain text, right? This is just this is the actual file that was sent from one of the test devices that I was using, and you can see it's showing, you know, not just the make and model, but how it's connected, where it's located, just a ton of information about the phone and the user and its state. And in addition to that, they're using a different analytics tool to monitor how people are using the app. That analytics tool is called Criticism, and that is also collecting a lot of the same information that Upside API is collecting. But it also includes things like the country code of the phone number of the device as well, because again, most people are playing it on their phones or on a mobile network connected tablet. It's a way for them to monitor who's cheating, because they're looking specifically at combinations of metadata about the phones itself that would indicate whether or not the phone has a propensity to be doing bad stuff. They're still working on that. I think that's a hard problem for them. All right, so here's another interesting one. In April, we stumbled upon an exploit kit that was delivering ransomware to Android devices, and so this is something that I would typically do, is I do manual browsing around sites that have a propensity to do bad stuff, and I allow those sites to infect the machines, and then we allow the infection to just progress and run for an extended period of time. Typically with Android devices, we generally see there's sort of two ways that Android malware will get onto a device, and it usually involves some form or some degree of user interaction, whether or not the user is prompted with either they get redirected to a page on Google Play for some crappy battery saver app or something, and then they have to click install in order to do that, and then go through the regular install process where they download it and see the permissions and have to accept them. Or sometimes you see these malvertising sites will redirect to an APK that's been hosted on some server somewhere that's not Google Play, and that they use that. They basically push the APK down and assume that you have third-party sources turned on in Android, and then the install just starts happening, and you have no idea why. You just see the pop-up dialog box again that asks you for it says what permissions the app is asking for, and because a lot of people will just click anything regardless, most of the time these things work. So here's the device that we used. It was a Galaxy Tab 2 stock browser and running CyanogenMod, so it was running Android 4.2.2, and this is just one of our test beds that we use all the time. And there's these feeds of bad URLs that come to us daily through our system. And this one's called Popular Site Monitor. And what it does is it shows what are the top 10 sites who are referring to the most malicious sites. So pretty interesting stuff. But you can see like the first one on the list is a porn site, and the next one on the list is an ad site. And we still see that, generally speaking, these porn and advertising are the referrers to most bad stuff. So this one day that I was using the Android device, and I was walking through the list of the pages that are in that email, and I just browsed to them, and the first thing that happened was this weird pop-up appeared that says, "Update now, please read. Do not turn off or reboot your phone during update. Please try again later." Interesting, because it's running CyanogenMod, and it doesn't get over-the-air updates unless you go and ask for them. So, and there hasn't been one for this particular version of Android, at least in the release channel, for a couple of years, which is why it's still running 4.2.2. So interesting stuff. So I just kind of hit the back button, and this screen went away. But then a minute later, this thing popped up and filled the screen, and it was this weird Android ransomware. And you can thank me later, but I've blocked out the piece that shows the person and a dog doing something really nasty, which is why we called the malware Dog Spectus. So what it says is your device has been locked. Reasons indicated below, with a timer, and then there's actually some metadata here that actually has the Google account name, the IP address, the public-facing part of the IP address that I was on. You can see that it says Device OS Samsung. It actually had the model and stuff, and then Device OS 4.2.2. At the bottom here, right? And then apparently there was some activities that has been undertaken on my device that it found to be illegal, right? And it was all valid, right? Because Jay Johnson, the head of Homeland Security, signed it himself, right? This is his personal note that you've been doing bad, right? So what it was doing was asking me for $200. But what was interesting about this attack was that it all happened with no user interaction whatsoever. I never at one point saw that dialog box that was asking me to install something and have permissions. Awesome. Go into security analytics, right? And the first thing you get is the exploit, which looks like this bunch of JavaScript. And I did not know what it was. I had no idea how it worked. But I knew that it was referencing something called XSL transform. And I did know, that there were certain characteristics of it that looked really familiar. So when I started doing my research on this, I contacted a really smart researcher named Josh Drake, who works for a company called Zimperium, and I asked him for some help because I don't know what this is. And he came back to me, and subsequently another guy who works in our company came back to me, and they both said, yeah, we're pretty sure that this was the leaked hacking team exploit against XSL transform. So as far as we were aware, this is the first time that we had seen the hacking team exploits being used in an exploit kit to deliver malware. So it was pretty exciting to see that. From a researcher perspective, really bad for mobile device users, right? What this thing did was it sent this exploit. The exploit delivered an ELF file, right, an Android executable, directly into the operating system, installed as root on the device. And that app was another interesting tool called Towel Root, which is a rooting, it's basically an open source root tool that people use to root their Android devices, right? So we see they were using Hacking Team to install Towel Root, and then they used Towel Root to install this. So it came down from this weird website, directbalancejs.com. As an HTTP post, it sent up a short query with that string in it. And what came down was basically a post data response that contained the APK in it. So it delivered the APK, right? It says net.prospectus. Okay? And then it was kind of cool because it when it's finished installing the app, it then contacts and it says final. And as part of the final configuration on this particular piece of malware, there's no command and control URL that's embedded in the APK. It actually writes the string directly into the APK to a memory location where it knows it's installed, which I thought was really cool. So whenever they install this particular piece of malware, they can, after it's installed, they can send they then hard code the command and control address into it, but they can do that after it's installed. I had never seen that before. That was really neat. So here's the slice out of security analytics that showed the flow of this, the malicious traffic that was involved in this exploit kit. And so what happened was, so the original site that was visited is called ziphorn.mobi. And there were 2 parallel advertising calls that happen at the same time, and the one that follows the red line is the flow of stuff that was happening that led to the malware, but there was a separate set of ad calls that were benign that went to regular advertising sites. So we had these IOCs that we were able to get out of it thanks to, most of this stuff was all through SSL, but we were able to figure it out. We knew what the servers were. So then we plugged it into our tools, the ad network, going back one stage. So there's this, the second link in the thing is terraclicks.com. So we plug this into our internal research tool, and it's kind of in the center there. Terraclicks.com has a few IPs associated with it, and the things that have the little nuclear symbol are known malware hashes. And when it's an arrow pointing towards something, it means that it's the malware is communicating with that server. So there's a couple of malware that was communicating with either terraclicks.com or the IP address that it was hosted on. And that was kind of cool. But then the longer we let this run, we started to see that there was this elaborate network of malware that was all communicating with the servers that were connected to these ad networks and that was hosting these ads. And just to show you, that one that's in the red box there, that's terraclicks.com. That was the one we started with. And you can see how much it branched off into this really bad network of a bunch of different malware that was all talking to the same stuff. The other thing we looked at was the end of that infection, right? So the direct balance JS is right here, and another URL that was part of the attack, image tums JS, is right here, and they're tied to another really bad set of IPs. If we showed all of the stuff that was here, it would fill the whole wall with all these bubbles of different relationship connections between these things. But the main thing is that these guys at the center are at the hub of a really bad network of a lot of malware. And it was really cool to discover that. And by looking at just these few domains, we were able to discover a whole lot of newer IOCs that we weren't aware of, that weren't really part of the initial attack. But when we started looking at them, we found that they were connected. Right? And then one of the things that was notable was that off to the bottom here and off to the left was this one domain registration email address, danielmcano@mail.com. And it's fake, and all the whois information is fake, but it was the one domain that wasn't private whoised in the whole attack, and it was connected off to the side to this thing, adastra.pro. And I thought that was kind of cool. That's their site that they were using to sell their services from. So, so we're at 11:45, and I can show you some more examples of bad stuff. If you guys want to see a little, I can drill into some security analytics. Are you interested in that? We got more time, so I can show you more stuff, or you can just take off early. It's up to you. What do you think? Show of hands, want to see more stuff? Yes. What was that? Well, feel free to jump in. So if you have any questions or comments, please.
Yeah, okay. I think this is one of the most boring trends I'm seeing. And I mean, there's a lot of strange stuff coming out from security products.
Okay.
But here, it's like security products are actively trying to subvert another security feature that's basically working. And I've said earlier in talks that I think each of these products is in some way reducing the security of TLS, and nobody has challenged me on that. I mean, I have never touch one of the devices because they're probably too expensive, but like all the products that are testable, like antivirus that's using TLS interception, each of them in some way disables some TLS security features. And one concrete question I could ask is like, how do you handle HTTP? Because that's basically the thing that all of them disable.
I'm sorry, what was the thing that? I don't know what.
Public key.
Okay.
It's interesting that you don't know if you work in this space.
I'm sorry, it's your accent and I'm having a hard time hearing you.
Okay, so HTTP.
Right.
Do you know that? Or
You mean package?
HTTP public key.
Right. No, I talked about key pinning. Key pinning. Yeah. No, that's true. I didn't talk about it in the context of the web. So the comment was, it seems like some of these features, these security products are designed to subvert or to reduce the amount of security of other security features. So it's an interesting discussion, you know, and yes, I use the product, but I don't build it, and I'm not a crypto expert, so I'm apologizing that I don't know how all of these things work. I would love to, if you have examples of websites and want to come up to afterwards, and we can actually walk through, like visiting a few of these websites and doing some inspection on what works and what doesn't.
I can comment on this because we own a lot of your equipment.
Okay.
We work for a large entity, right? We've got 400,000 employees.
Do you want the mic so you can be heard?
Well, so everybody can hear my drawl.
Yes, please.
I'm not loud. Can y'all hear me? Yeah, we got you. All right, so we have an SG SSL-VA sandwich, right? The SG's on top doing the filtering.
SG, by the way, is the proxy.
Right, and then we've got the SSL-VA on the bottom. And I hear exactly what you're saying, right? We're kind of undoing the security that's built in. But we don't want that in our entity because what we're really looking for are internal threats that are communicating with the outside, right? So we use the tools to not only choose what we want to re-sign and decrypt, and then we use the VA to feed into the various other tools because IPSs are great. They don't work on encrypted products, right? And if you've got an internal customer that's using a client-side certificate or a private PIN cert, right? We've just lost the ability to see into it, so we will actively block it. They'll come to us and say, hey, this is broken, I can't do it. We then have to go through a risk assessment to find out what is it that you're trying to do. Right now, if we're a home user, right, you want the private pinning because I don't want Akamai and the handful of other bastards that sit in the middle and subvert my traffic to see what I'm doing, right? That's why I've got the private pin. But from a large entity perspective, that's a dangerous tool, right? And it goes back to what you said, or somebody had mentioned, if you're on an enterprise machine, you have to click OK, right? And you're dumb if you're on your work computer and you believe that you're not being monitored, right? We watch everything.
Right, and we're not reducing the security for people who are using this at home or who are not on a corporate network where they know that the corporation is feeding the network to them and could be surveilling it. But again, you know, and we're not reducing the security level on the certs. But you know, it's a valid point that, you know, there are certain things that this will reveal in the course of you doing stuff, but it's a trade-off because there's enough of the really bad stuff that's using SSL. I mean, again, would you, and I'm not saying that it's a philosophical discussion, right? Do we allow the bad guys to use our own privacy tools against us to steal stuff and take it places, you know, and do bad things? Is that okay?
That goes from the assumption that your product will catch all of that. And, I mean, that goes back to the discussion whether antivirus is working.
Right. I mean, okay. So yeah, and then yes, that's true. That goes back to the discussion of whether or not our product will cover it. But like, say, if you want to, if you want to allow users to have certain private interactions, like you want them to use Gmail and stuff, you can just exclude it. And again, it comes down to a risk assessment on an organization by organization basis. It's not pure. It's not the best, purest security. Let me tell you something else. The SSL Visibility product does not decrypt Tor. So if you really want to use Tor to make sure that you're basically private, entirely private, you can try to do that. And on a policy level, the proxy can block Tor. And again, you then have to go to the guy and explain why you're trying to use Tor at work. But you know, the point is that like there are solutions that will basically either not allow you to communicate in an insecure way, or that will protect your communications. So I mean, this is. It is, again, that's why I said it's not a magic decoder ring. It's not going to work in 100% of cases. Go ahead. Well, it's all tied to the projector. Yeah, just come on up.
And I saw your talk on TLS, by the way. That was awesome.
Huh?
That was great. Your talk on TLS 1.3. I saw that at like that.
Yeah, okay, thanks. So you're saying that you're expecting this is to be used in a corporate network where the users are aware of it. Well, first of all, I had users contacting me about weird stuff, and it turned out this was used and they had no idea what was going on there. So that's why I earlier asked if you have ever tried to assess whether it's really true that the users are aware of this. Yeah, and...
I'm sorry, you're saying that some of your users...
Not my users, like people contacting me because they know I know about this stuff. And
But it was a Blue Code product? I mean,
I don't know that.
Okay.
But like corporate networks,
so
there's
so in addition to us,
But-
I mean, there's other proxies, including open source projects that
Yeah.
do SSL inspection. We
But-
just do it
yeah.
with custom silicon. That's why ours is fast, but it's not unique
Yeah.
in any way.
But you said you don't know whether your users know that when I asked earlier.
I don't speak to users.
Yeah.
But you know, we do when we sell the product, and I'll answer that question. So when we sell the product, you know, we make it really clear. Everybody who's aware of what this inspection does understands what the law is in the United States, at least in North America. You have to provide some kind of notification where you're doing inspection or where you're doing surveillance on an internal network. And so I don't know whether they understand it, but I mean, I've spent the last 15 years doing user education, and people still don't understand that they shouldn't open, you know, zip attachments that they get from some random person that contain an executable either. So, you know, you could keep coming up with hypotheticals, but to me it all comes across as kind of red herrings. I mean, we try as hard as we can to tell the users, to tell the public, to tell the customers, to tell their users, and a lot of them will notify every time they log in. But if the user, I mean, you can walk around with blinders on and still miss a whole lot of stuff too. People play Pokemon Go and walk into posts and fall off cliffs, right? At a certain point, user education just goes so far.
Yeah.
If they're not aware, they're
And
not aware.
that was just a minor point. I mean, I think there are a lot of points to this debate. I can point out that I last year on CCC Camp, I did a whole talk on this issue where I kind of tried to make the point that I think these products are by design misguided. So yeah, and I'm happy to have this discussion afterwards. I think I'll leave it with that, but
Okay.
yeah.
And that's a fair point. I mean, you're welcome to your opinion, but I've seen enough really bad malware that's using SSL. So Trojan Dire or Direza was one of the really bad APT malware that I was doing research on for the last 18 months. You know, it's pretty much died out at this point. But basically, everything they were doing was trying to circumvent security by using the strongest security possible to encrypt its traffic. And then they also tried using experimental stuff like I2P, which is kind of like a different type of Tor over UDP. And so I know that there are valid concerns about inspecting SSL, but the reality is that the really, really bad guys are using it too, and we gotta know what they're doing. We gotta know what they're doing because they're stealing stuff, and it's a free-for-all. Yeah, go ahead.
So a couple things on that is, one is governance, so like PCI or HIPAA, you need to notify your employees and probably have them sign off that they are being monitored anyway.
Right.
Another thing is, what you didn't address, like DLP at all in this. Does your product have any DLP add-ons or?
No, so again, the SSL Visibility, all it does is it feeds to other devices. So if there's a DLP tool that you use, you can plug the DLP tool into the feed, and it can see whether, you know, big batches of credit card numbers are going out the door to places that they shouldn't be, right?
And you also showed that all in the A configuration, there's another configuration where you can throw in an IDS or actually an IPS, and it will pause the data stream while it loops through the IPS, wait for an active acknowledgement that the data got through or didn't, and then resume the data stream or let it go or not.
Well, my problem with DLP right at the moment is that we have Fortinet, and sorry. I ain't saying who I am now. But right now we have it just set to log, but it captures all kinds of crap that it thinks is a credit card. And it's like, this is useless info.
You can't do DLP on chip. You have to do DLP as of today, has to be done afterwards, and there has to be a lot of processing done because of the way the packaging and fuzzing goes on. It's a huge deal. You need statisticians and people that really know how to munch the data to have true DLP done. I have yet to see anybody do it on chip.
All right. So question back here?
More of a comment. So if you're concerned about security, you need the SSL inspection, but clearly most of us are concerned about privacy also. I mean, it gets back to segregation of network. If you're in an enterprise and you set it up right, turning off SSL inspection for blue code categorized sites works for blue code categorized sites, but there's always an oversight. Just block all those sites on your network. You can't go to banking, you can't go to social media, and set up a segregated personal browsing network, because like users aren't going to know they're being monitored, and they'll definitely not know to what degree. Everybody clicks through everything, including all of us. Nobody reads the terms of services, so what we had done was we had set up a personal network. It's not an elegant solution, but there's a separate network for your personal browsing. You use separate systems, and then you have your business network that's heavily filtered, so you can't even go to those. So if the Blue Code SSL or whatever SSL admin makes an oversight, or goes rogue and wants to steal employee data, they just can't do it. Levels of control, levels of segregation. It also protects international companies with the data privacy issues for Europeans. Because if you've got those people coming over to America, what happens? I mean, I don't know if that's entirely clear. So on one side, we're not looking at you, but then over here we are. Like, that's not cool. Just from that side, let alone the legal side. To just segregate, which you should be doing anyway, right?
Right, and I would just make the point that I don't think there's a false dichotomy that's set up that's you have to lose privacy to gain security. I don't believe that that's true. I think it's a configuration issue, and it takes being smart about the way you set things up so that you can have both. And I really believe that. I don't think that you have to lose privacy in order to have security. So I'm sorry, you had a question or comment?
A couple things. Yeah. So, I mean, I think everyone in this room would fundamentally agree with what you said about privacy and so on. But, I think, your perspective, and I think my perspective working for very, very large, Fortune 100 companies, is that when you're on a very corporate style network, that there is no expectation of privacy, and that, IT folks will be monitoring and surveilling your data.
Right.
Yep. So the other thing about the ICAP, you guys already have a solution for that. So, the proxy SGs using ICAP protocol will communicate with other DLP solutions.
Right.
So that's already solved in my opinion.
Yeah. Please divorce from ICAP. Pretty please.
I can hand your suggestions off to product management, but I don't make those decisions. Again, all I do is I run malware and break machines all day long. That's all I do. And use our tools to look at what happens when the pieces fall. So now we're a little over time. So I just want to thank you very much for your comments and your interest, and thank you for providing the contrasting opinion. I really appreciate it, and thanks for coming.